So now you know at least one strategy for finding the distance around the outside of a circle, or its circumference. Today we will be analyzing the parts of a circle. Analyzing just means thinking about something. So today we'll be thinking deeply about the parts of a circle. So everyone can identify a circle when they see it. When you look at a circle, you know it. You can say, hey, that's a circle. But defining it is harder. Could you actually define a circle without using the word round? It's not easy to do. So, our next activity is a little investigation that's going to help us better understand what it means for a shape to be a circle, to mathematically define the term circle. So, here's your first step. In the space provided, draw a point and label the point A. So I've done that here. Now my next step is to find a point that's 5 centimeters away from A. Let me do that using my ruler. Of course, you're doing this in your book. There we go. That point's 5 centimeters away. Now I've turned my ruler a little bit and here's another one. I've turned my ruler again and here's another one. There's a few more. Now how many of these points could I draw? How many points that are 5 centimeters away from A could I actually add to this paper? What do you think? Let's keep going. What shape is this making as I go around? I kind of ran out of room in my top left-hand space over here, but that's okay because I think I have enough points on my paper now to establish that the shape that I'm really drawing is a circle. If I were able to connect these points perfectly, that's what I would have, right? And I could draw as many points as I wanted. I could add more in between these and I could keep drawing points all day long. So now I want you to pause the video and talk with a friend. Now, we asked earlier, could you define the term circle without using the word round? That's your challenge. Talk with your partner, and I want the two of you to come up with a definition of the word circle, but you are not allowed to use the word round, and you're not allowed to use the word circle. All right, it's time for somebody to share those definitions. Let's hear them. Pause the video and listen to your classmates' responses. And hopefully the definitions that you guys came up with are very similar to this one. A circle is just a set of points that are all the same distance from a given point. In the example we looked at, all of the points were 5 centimeters away from point A. And being the same distance from point A is what caused it to make a circle. So now that we know what a circle is, let's give this circle a name. The nice thing is this circle has already been named for us. This is circle B. A circle is named by its center. That's the name of this circle, circle B. Now, could you identify the radius of this circle? A radius of a circle is just a line segment that connects a point on the circle to the center of the circle. So this is a radius, and this is a radius, and this is a radius. Any point that goes from the circle to its center, any segment that goes from the circle to its center is a radius. The diameter of a circle, there's the word diameter, is a line segment formed by connecting 2 points on the circle so that the line segment goes through the center. So to draw a diameter, I would need to go from a point on the circle through the center all the way to the other side. So that's a diameter. From one side of the circle through the center all the way to the other. That's a diameter. What do you think? I want you to talk with a partner. Are all radii of the circle the same length? Why would you think so, or why would you think not? Go ahead and talk with your partner and pause the video. All right, I hope that somebody said yes, all radii are the same length. The reason that radii are all the same length, that every radius is the same length as every other radius, is that all of the points on the circle are the same distance from the center. And that distance is the length of the radius. The important thing for you to remember here is that the radius goes halfway across the circle, from the center to the circle itself, and the diameter goes all the way across the circle through the center of the circle. So here's one more question for you to think about with your partner. What is the relationship between the length of a radius and the length of a diameter? Pause the video and talk about it. Did you get stuck? If you're stuck, it's helpful to draw a diagram that reminds you where the radius is and where the diameter is. Remember, the radius goes halfway across and the diameter goes all the way across. Here's two ways to describe that relationship. The length of the radius is half the length of the diameter, or you could also say the diameter is twice the length of the radius.